Lin from Chongqing University in Taiwan, talking about reverse casting Taiwan red cypress distribution in central Taiwan from topographic sheltering effects of Taiwan fir in Hohuan Mountains.
Hello everyone, I'm Lin. I'm from Department of Forestry, Chongqing University from Taiwan. And today I'm going to present reverse casting Taiwan red cypress distribution in central Taiwan from topographic sheltering effects of Taiwan fir in Hohuan Mountains. And first of all, I'm going to introduce Taiwan. It's located in Asia and beside China. And my university is located in central Taiwan in Taichung City. Okay, today I'm going to present from introduction to conclusion. Ecological niche modeling, we call it ENM, is based on statistical method to quantify the relationship between the species, its distribution, and its surrounding. And we can go to map the distribution, potential distribution of that species. And in recent years, 3S, RS, GIS, and GPS improved quickly. And ENN coupled with GIS, RS, and GPS, we use it on a large scale, and we can quickly get useful information for monitoring and management for forest or environment. And ENN becomes an important tool for distributional ecology and conservation and public health. So ENN may be reconstructed by relating data on species occurrence with data set summaries, climatic, topographic, and other ecological dimensions. So we read some previous study. We find out topographic shelters formed by mountains protect Taiwan fir from high wind so that it can grow well in the valley or depressions, but there are no any Taiwan fir on the ridge or the peak. And we can see this picture. Taiwan fir in the yellow circle, we can see Taiwan fir grows well in the valley and depression, but in the black circle, we can see there's no Taiwan fir on the ridge and peak. And this is another case for Taiwan fir. It has the same phenomena. And here's another same topographic sheltering effects in Nika in Malawi National Park in Africa. And we can see in the blue circle, there's plants grows well in the valley, and also in the green line, there's no any plants on the ridge. And also there are two types of models for our ENN modeling. The first one is species present an absent, we call SPA. It needs present and absent data for our modeling. And also there's another type of method we call species present only. It only needs the present data for our modeling. And in our study, we use GLM and ML for SPA and use Maxent and Geo and BioClean for SPO. So we have three targets. The first of all is we are going to evaluating the effect of different training sample size on the performance of each method. And the second one is we are going to compare the advantage between SPA and SPO. And the last one is the most important one, is we are going to confirm current use, predictor, variables, except elevation to be used as for explaining the absent TRCs in most Huizun area. And here's my material and methods. First of all is our study area. Our study area contains a whole Huizun forest station, and we adapt it with spot file image and expand it into a rectangle area. It contains 17,136 hectares. And also we can see the blue area. This is our sampling area near the Southern Mountain, and it contains about 88 hectares. And this is our target species. We call Taiwan red cypress. It's one of 5 major softwood in Taiwan and major grows in Central Mountain. And its elevation is most falls within 1,500 to 2,150 meters. And also it normally grows in fog forest belts. And this type TRC just look like, and it's cone, seed, leaf, and tree barks. And what is fog forest belt? It belongs to mesothermal deciduous forest, and its elevation is about 1,800 to 2,500. And its most important feature is that its relative humidity is about 81 to 94%, so that it always looks like just like this picture. Here's my major step and flow, and I'm first going to introduce our sampling. Our sampling point is from this forest type map, and we also coupled it with ground survey. We can see in this red circle near Sochen there's a pure forest of Taiwan red cypress, and we compare it with the third forest results and land use in Taiwan, and we found that the result is the same, so we directly digitize this area for sampling. And here's our variables, and in the blue one, topographic sheltering is under development, so we won't use this variable in our studies. So we get elevation, slope, aspect, and terrain position, and vegetation index for our study. And also, in the future, we are going to use the topographic sheltering. Although we don't use this variable in our study, but we think this is the most important or key variable for our study in the future, so I'm going to introduce it. This variable's concept is according to windbreak forest, and the other one is the point in polygon. And also, it considers the horizon distance protected by the topographic obstacle is roughly 15 to 20 times the relative height. It means that if the horizon distance is more than 15 to 20 times, it has the relative height. It won't have any topographic sheltering effects. And we can see this picture. 1 to 8 is our obstacles, and the target cells A and B. We can find that A has better topographic sheltering effects than B. And this is a concept of point in polygon. And finally, we use this function to calculate it. And here's the opposite concept of topographic sheltering we call fetch. It also considers distance to the obstacle, but it's a concept of exposure. According to Lapin, it considers the 8 coordinate compass direction and use this function to calculate it. But in Genesis, it can consider the mean distance is 360 degrees direction, just like this picture, and it also consider the dominant wind direction, and use this to calculate it. And then I'm going to introduce our sample selection. We randomly select 5 sample sizes for comparing, and we get the background is 5 times more than our training points. And finally, we use the independent sample to validate it. And this is our 5 sample size. Finally, when we get our sample size and our variable, we overlay it and clip it to get our habitat and non-habitat data. When we got our data, we are going to do model development. And in our study, we use GLM, ML, XN, and BioClean. GLM contains a random component, systematic component, and link function. And the systematic component is x1 to xk. It means the variable we use is like the elevation. And we use link function to link it in a linear function. And ML, it selects value of model parameter that produce a distribution that gives the observed data the greatest probability. In this picture, just like we will find according to our sample point and find the greatest probability, and use this function to calculate it. And the maximum entropy, the entropy is based on the entropy in thermodynamics and base statistics. And makes us choose the one that maximizes entropy, which is closest to the uniform condition. When we put different variables in it, we find the maximum entropy, and this is the closest to the uniform distribution. And the last one, BioClean, is the environmental element. We replace the 5 to 95% limit. It will calculate disregards 5 points, just like this picture. Finally, our model validation will adopt kappa index, and kappa index is consider the commission and omission error and use the error metric and following function to calculate it. And then I'm going to introduce our results and discussion. First of all, we can see in the 4 models our variables, we can find that elevation and slope was the most important. And the topographic shortening is under development, so there's no value for this variable. So we use elevation and slope for following analysis. And we compare the 5 sample size. We can see in five models, we can see that ML is better than GLN and Bioking and Maxen. And we compare SPA and SPO. We found that SPA is better than SPO in our study. And finally, we can see that 4 model cannot improve significantly until it reaches the sample size of 351. So we use 351 and elevation and slope to produce our potential habitat map. And here's our map. The GLM, we can see the TRC only presents near Southern Mountain, and we can see its prediction is more expanded. So during this area, we can see that in yellow circle there's more commission error in this map. And also in ML is similar to GLM. We can see this area here is more commission error. But Maxen is similar to the other 3. Its TRC is only present in near Southern Mountain, but we can see that its prediction is more limited. So we can see there's a more omission error in this map. And Bioking is similar to ML and GLN, so it has more commission error than omission error. And we finally found that Horizon area that in its northeast there are 3 main ridges in Taiwan. We think that it blocks the humidity and winds to enter our area, so our area has lack of humidity. And here's our conclusion. The predicted accuracy of 4 models generally lived with the increase of sample size until it reached 351. And accuracy of SPA is better than SPO in our study. And the performance of 4 models, we found that ML is better than GLN and Bioking and Maxen. And Maxen is significantly worse than the others. And we found that except elevation, the value we use that is useless for explaining the absence of TRC in most Huizun area. So that we found that there are 3 ridges to block the wind to enter our study area. So we will attempt to incorporate the proxy indicator, just like I said, the topographic shortening index of climate factor into ENN, so that we can improve our accuracy or prediction of our TRCs. Thank you.
We've got time for questions.
Okay, firstly, thanks for your presentation. Just a comment. I know this is a very local case, right? It's a local case.
Yes, local case.
So, I suggest it would be better if you select several samples at the same latitude and altitude. So maybe you can get more general findings. Okay, it's my comment. Thank you.
Okay, thank you.
Thanks for that comment. Any more questions from the audience? Okay, I'd like to thank again all the speakers. I think this has been a pretty interesting session, so thanks for everyone's contribution. And we can have a break. We'll go down to the posters, I guess. Okay, thanks again.